Welcome to our podcast of the second and third grade math night that was held earlier this year. You will be listening to Sam Clegg and Kim Utakis, both math coaches for District 96. In the podcast, we will be reviewing the Common Core areas of focus for each grade level, reviewing the standards of mathematical practice, looking at conceptual knowledge versus operational skills, learning addition and subtraction and multiplication and division strategies, and looking at some fraction concepts in third grade. In second grade, the Common Core critical areas are expanding their understanding of base 10 notation. We are working on building fluency with both addition and subtraction. We are using standard units to measure, and second graders will also be describing and analyzing shapes.
For third grade, our third grade students will be developing an understanding of multiplication and division strategies, focusing on the basic facts for multiplication and division within 100. We'll also be developing some early understanding of fraction concepts with a focus on unit fractions. We'll be developing an understanding of rectangular arrays and using multiplication to find area. And lastly, we will be describing and analyzing two-dimensional shapes based on their attributes.
Okay, the standards of mathematical practice are 8 things that all good mathematicians do. So you will notice that number 1 and number 6 are highlighted, and those are the overarching areas of practice. Those two fit into any topic of math that the students will be studying. Some are more appropriate for certain targets, such as using tools strategically. That may be more with a measurement target. But 1 and number 6 are where we focus a lot of our time with the students because those are the most important that apply to each target. Okay, now looking at conceptual knowledge and operational skills, we want students to be able to show their thinking and be able to prove that their answer is correct. Rather than assessing a certain strategy or method or algorithm to find the answer, students are given more of a freedom to be able to select their own method, but then be able to show why they chose that method and then how that worked to let them arrive at a correct answer. This is helping students really gain a deeper understanding of place value, understanding the why behind the strategy, and ultimately we want students to be able to find the quickest and most efficient way possible. So through that understanding, being able to find a quick way for them to be able to solve the problem. Okay, we are going to be looking first at some addition strategies for second grade, and this first video is going to show you how students can use base 10 blocks to add two-digit numbers. In this one, you'll notice there is no regrouping or carrying, but this is where students will be starting in second grade. We are going to look at using base 10 blocks to help us add two-digit addition problems. And in second grade, we start out using base 10 blocks, the manipulative models, to really help us see what each of those digits is representing and what happens to those digits when we are adding them or joining them together. So I am going to start out by drawing base 10 blocks for the number 24, and you will hear your child at home call the tens blocks longs, which is shown just by drawing 2 sticks. And they will also be referring to the ones place, the 1 block, as a cube. And that we can just draw a dot or a square, whatever they're comfortable with or are using in their classroom. Either one is fine. Then I'm going to do the same thing for the number 32. 3 longs and 2 cubes. And now it's as simple as just counting each of those type of blocks. So I have 1, 2, 3, 4, 5 tens, which is telling me I have 50, And I have 1, 2, 3, 4, 5, 6 ones. So altogether, I have 56. This next video is going to show how students are able to how students are able to add when they are needing to regroup the ones to show another 10. In this problem, we are going to continue to use base 10 blocks, but here I'm going to show you what we have to do when it's necessary for us to regroup our ones blocks in order to make another 10. So I am going to start out just like we did in the last one with first drawing my base 10 blocks. So I will have 3 longs and 4 cubes. And then I'm going to draw 2 longs and 7 cubes. So here I'm representing each of those add-ins with base 10 blocks. Now I can see that I can make another group of 10. So I have my 7 and 3 more to make another group of 10. So I'm going to just draw another long next to that. So I see that the 10 cubes is the same as the 1 long, each representing 10 in our number. Now I'm going to do the same as before. I'm going to count up my longs. So I have 1, 2, 3, 4, 5, 6. And I have 1 cube left. So the sum of our problem is 61. This next video shows how students can decompose the numbers 52 and 37 into the tens and ones. So this is moving students from the picture or the model into using more number and procedural based strategy. We are going to work through this problem together. So the first thing that we need to do is decompose 52 into its expanded form, which would be 50 plus 2. And then we are going to do the same thing for 37, which is 30 plus 7. And then I can join my 2 parts together. My 10s I can join together, and my 1s I can join together. So when I add 50 plus 30 together, I get 80. When I add 7 plus 2 together, I get 9. And then finally, I am going to join those last 2 parts together for a sum of 89.
All right, so moving into third grade and building very much off of what second grade did with addition, we start with an algorithm called partial sums, and we might start with 2-digit and we'll move to 3-digit. So here's a video showing how partial sums works in third grade.
So for partial sums, we do a lot of the same thinking as we do in second grade. The only difference is we structure it a little bit differently in order to promote efficiency. So in second and third grade, we're moving from more of the concept of addition subtraction, moving towards fluency with addition and subtraction. So that's what we're going to work on here. So we think of it the same way, where we look at our 35 and our 28, and we think of it as 30 plus 5 and 20 plus 8. More of our work is done mentally here, though. So I ask myself, 30 plus 20, that gives me 50. And then I have 5 plus 8, that gives me 13. So all together, when I add up my This is my hundreds, and this is my tens. Altogether, I have a sum of 63. Now let's take a peek at what it looks like with 3 digits, which will be more of the expectation of a third grader. So we may start with 2-digit numbers in third grade to build background knowledge, but our goal is 3-digit numbers, as the target is to add and subtract fluently within 1,000. So here we go. So let's start with our hundreds place. 200 plus 200 is 400. Then we'll move to our tens place. 70 plus 50. Now this is where a lot of third graders have trouble. A strategy that might work with your child at home is to start with the larger of the two tens and count up by 10. So we'll start here with 70 and count up. 70, 80, 90, 100, 110, 120. Altogether I have 120. So the reason that one causes a lot of confusion for kiddos is there's something about adding those tens that a lot of times they'll want to put 112. And so counting by tens helps them see that it's 120, not 112, and to see why. So lastly, let's add up our ones place. So I have 6 plus 8 is 14. And so then I take all of my partial sums. I have my all of my hundreds, all of my tens, and all of my ones, and I add them together to get a total of 534.
All right, I'm going to go ahead and apologize there because I realized in my video I made a mistake, and here in this problems it should have been my tens and my ones, whereas in the video I said hundreds and tens. So I apologize for that mistake. So the neat thing about partial sums is that it really leads to deeper meaning as to traditional addition. So here we can see that when I added my tens, my 70 and my 50, and got 120, this 1 is actually in the hundreds place. And when I added the 6 plus the 8, that 1 here is actually in the tens place. So when I move to traditional, I understand why I'm regrouping that 1, because it's 14. It belongs actually in the tens place. And here I'm regrouping this 1 because it actually belongs in the tens place. So it brings meaning to that step. And again, always with a goal of moving towards efficiency. We hope third graders are feeling fluid with this traditional addition algorithm by the end of third grade.
Okay, now we are moving back to second grade and looking at some subtraction strategies. So again, first we are using base 10 blocks to help build that foundational understanding about why they're doing using the numbers in a certain way. So this way first is showing us without any trading. So a common mistake that second graders make when they begin to use base 10 blocks for subtraction is that they want to show both of the numbers, the 56 and the 24, in base 10 blocks as they did with addition. So just make sure as you're working through some problems at home that they are remembering to only represent that first number with the base 10 blocks, and then the second number is what they're taking away or crossing off from that model of the base 10 blocks. So in 56 minus 24, they're going to draw the tens and the ones to show 56, so 5 tens and 6 ones, and then they will need to subtract the 24. So they can cross out 2 tens, cross out 4 ones to have a difference of 32. Next, we are going to watch a video of how to use base 10 blocks when students need to trade in order to be able to subtract the ones.
Here we are going to see what we need to do when it is necessary for us to trade a 10 in for 10 cubes in order to work through our subtraction. So I'm going to start again by drawing my base 10 blocks, but this time remembering that I am only drawing the base 10 blocks that represent that top number. And then I'm going to be subtracting 17 from that set of 32 base 10 blocks. Now when I look at my ones place, I see that I only have 2 ones. I do not have enough to subtract 7 ones. So what I'm going to do is trade in 110 for 10 ones. Now I have enough to subtract 7. So I'm going to cross them out, and we'll get rid of 1, 2, 3, 4, 5, 6, 7. Okay, and now we still need to subtract our tens place, and I have to subtract my 110. And now we can count what we have left. So we have 110 and 1, 2, 3, 4, 5 ones for a difference of 15.
Okay, so building again off of second grade subtraction strategies, third grade starts using trade first algorithm. So we might start in third grade using 2-digit subtraction and building up to 3-digit. But this video is going to show you what trade first subtraction will look like with no trades, or just with a single trade, I'm sorry. And then we'll also go into what it looks like when there's more than one trade. And so here we go.
So we're going to go over trade first subtraction. We're going to go over how it looks when we have a single trade, which is just one trade within the problem, and then we're going to look at what it might look like with more than one trade. So again, the reason we call this trade first subtraction is whereas when we grew up, we would trade and then subtract, trade and subtract, and so on and so forth. But we have found that it's more efficient if the children do all of their trading before subtracting to ensure more accuracy. So I will show you what that looks like. We also encourage that your child start from the left of the problem. On the next slide, we'll go through why that is, but for now, I'll show you what that looks like. We're going to get the same answer either way, but there's something about starting from the left that in certain cases makes it more efficient and meaningful. So here we start and we ask ourselves, can I take 300 minus 200? I sure can, so that column is good. Next I ask myself, can I take 70 minus 50? I sure can, I have enough. And lastly, can I take 4 minus 8? And in that case, I do not have enough, so I have to come over to my tens place, and I will borrow just one 10, picture in my head breaking it up into 10 little ones, and now altogether I have 14 ones. So I look back over, I make sure I'm ready to go, and I can subtract. So now I can say 14 minus 8 is 6, 6 minus 5 is 1, and 3 minus 2 is 1. So next, let's take a peek at what trade first subtraction looks like when we have more than one trade. So we'll start with our same questions. Can I subtract 300 minus 200? I sure can. Can I subtract 20 minus 50? In that case, I do not have enough to do that, so I will come over to my 100s place. I will take one of my 100s, turn it into tens, and now I have 12 tens. Now, can I take 4 minus 8? I do not have enough, so I will go over to my tens place. I will take one of them, break it up into little ones. Now I have 14 ones. As I look, I check over again. I can subtract that, I can subtract that, and I can subtract that, and I am ready to go. So I can go ahead and subtract. So 14 minus 8 is 6. 11 minus 5 is 6, and 2 minus 2 is 0. So my difference here is 0.
Okay, so here is where why we often encourage children to start from the left. So I will, let you know that if they start from the right, that is okay. It would not be considered incorrect. This is just the reason why we would start from the left, because in a situation like this where we have 400, if a child were to start from the right, they'd have to go to the tens place to trade, but there isn't enough there, so they have to go to the hundreds place. And it results in starting from the left anyways, so we're just taking out that step of having to do multiple jumps in order to trade. So that would be the reason we encourage that. And also with Trade First, children, we want them to be fluid with this algorithm, but we also want to encourage your child to think about if that algorithm is the most efficient strategy. So we do a lot of work with mental math. So here, a lot of children, if they see 302 minus 298, would jump right to Trade First. But really, we want our children to think deeply about estimation. And here, if I look and say, wow, both of these numbers are very, very close to 300, I could probably do this mentally and know that 298 plus 2 would give me 300, plus 2 more would give me 302, and solve that mentally. So we're looking for, to build that ability in your child as well. So moving on to multiplication and division. So within third grade, we are going to expect your child to fluently multiply and divide within 100 by the end of third grade. This will be chunked out throughout the year, and that is outlined in the pacing guide available for parents online. So, but along the way, we will be working on lots of different strategies. So although a child may not need to master a particular fact in Unit 2, they might still be exposed to that fact and be expected to use a strategy. So here is where we start with multiplication and division, is using arrays. So here, if we look at this array, we could ask the children, do you see 2 times 3 in that array, or 2 groups of 3? Which they could see, here's my 2 groups. Each group has 3. Or we could ask, do you see 6, a total of 6, divided into 2 equal groups, and ask how many are in each group. So really working with arrays for both multiplication and division begins to build that relationship between those two operations. Another question we can ask with this array is, just imagine in your head, what would this array look like if there was 2 groups of 4, and have them start to imagine the arrays in their heads to build that visual image. So, like I said, we're really looking to build the relationship between multiplication and division. So here, using that same array, or using array in a certain way, we would look and say 12 divided by 2 equals what? Or 2 times what equals 12. We want your child to really think about division as a missing factor problem, because as adults, that's typically, that's the way we often think about our facts as well. So being able to fluidly use either one of those strategies to multiply. Another strategy we'll use beyond arrays for multiplying and dividing is to decompose numbers. So here's a video to show what that will look like.
We're going to talk about how we can use a strategy called decomposing to help us multiply when we are dealing with facts that we aren't sure of, or facts that we haven't yet memorized. So, for example, we'll start with 3 times 8. I don't really know my 3's and I don't really know my 8's. So let's say it's early in the year and I have, maybe my 1's and 2's memorized. I can look at this 3 here and know that within the number 3, I can actually break that up into a 2 plus 1. And so really what we're doing is helping our children distribute. We aren't going to tell them that it's distributing, but really that's what it is. And we're going to distribute this 8 and do 8 times 2 and 8 times 1 and bring them back together. So let's try it. Let's do 8 times 2, that equals 16. And we know that 8 times 1, that equals 8. Now, let's add those two together. 8 plus 16 is 24. So I know that 3 times 8 equals 24. There are other ways you can break up these numbers besides breaking up the 3 into 2 and 1. If your child knows their 4's really well, they can choose to break this 8 into 4 and 4 and do 3 times 4 plus 3 times 4. There are lots of ways to do it. Our goal is to help your child use decomposing to break the factors up into numbers that are helpful to them. So if they don't know their 5's and 3's, it would not make sense to break 8 up into 5 and 3. So you want to break it up into numbers they already know. Let's move on to the 12 times 8. Again, I don't know my 8's, but we've worked on our 10's and our 2's, and I know that I can break a 12 into 10 and 2. So I'm going to distribute my 8 times my 10 and my 8 times my 2. And say 8 times 10 is 80. and 8 times 2 equals 16. So altogether, I know that my product will be 96. The cool thing about decomposing is that it also promotes mental computation. These are things that kids could potentially do in their head as well as on paper. So lastly, let's tackle 9 times 6. Let's say for this one, I don't know my 9s or my 6s, but I do know my 5s and my 1s, and I know that I can decompose this 6 into a 5 plus 1. I know my 5s and I know my 1s. That makes it a little more manageable. So I'm going to do 9 times 5 equals 45, and I know that 9 times 1 equals 9. And when I add those two together, I get a total of 54. So you can see how this strategy can be really useful for your child to tackle larger numbers, especially when we get into two-digit numbers. Thinking about this 8 times 12, in third and fourth grade, they're going to start multiplying multi-digit numbers, and really what they're doing is decomposing them, just like we did for number 12. So it's a great strategy to encourage your child to use at home when working on multiplication and division.
Okay, so next we're going to talk about area and how multiplication is going to be connected to area.
So when we start working on area, we're going to start really basically by counting what we call unit squares or tiles. At this point, we're not really exploring different units, such as inches or centimeters or feet. We're really talking about just counting squares and building the concept that area is the amount of space within a given shape. So here, when we start with this, we'll start by counting squares. 1, 2, 3, 4, all the way until we get to 18. Our goal is, while we still have these squares, these grids within the shapes, is to build your child's connection to arrays and see that, wow, instead of counting 1, 2, 3, we can actually see that I have 3 groups here and 6 squares in each group. I can use what I know about multiplication to find the area instead of taking all of that time to multiply. So we're starting from counting squares to multiplying unit squares in order to find area. So from there, we'll come to where maybe we take the squares away, and now we don't have them anymore. Your child can choose to draw them in if they'd like to, or build the array, but our goal is to hopefully have built this concept strong enough that they don't need it anymore, and that they will be able to successfully know that to find area, I just need to go 3 times 6 and know that the area is 18 inches. And we have taught them squared or square inches because we're talking about squares when we're talking about area. Now we'll move into more complex area problems like this one here. The goal for a third grader is that they can understand that area is an additive. And what that means is that we can take 2 smaller areas and add them together in order to find a larger area. So that's what this problem here is telling us. So what we're going to think about is that for this rectangle, this one here, we have 3 by 4. So I'm going to multiply 3 times 4 and get 12. So I know that this rectangle is 12 inches squared. Now I'm going to look at that smaller rectangle and see that I've got 2 by 3 equals 6. So this is 6 inches squared. And you'll notice here that the side is not given. For your child, we'll usually give them the dimension, so they won't have to assume that this is 3, although it'd be a nice goal for them to get there. We would provide that dimension for them. And then what we would do is take both of those areas and add them together to find a total area of 18 inches squared. So we continue with that idea of being able to decompose a shape, a rectangular shape, into smaller rectangles in order to find the area of those and add them back together. Now we get a little more complex down here with this L-shaped figure, which your child will likely come across this year. So you'll see we've got two rectangles. We've got a bigger rectangle here and a smaller one here. You could also see this as a more long rectangle here and then another rectangle here. Either way, you're going to get the same answer, which is nice. So we will start by figuring out where do we want to break this rectangle. So we're going to draw a line right here and say that I'm going to find the area of those two rectangles. So the hard part about this is ensuring that your child is locating the correct dimensions to multiply by. So let's first start with this smaller rectangle here. They see a 6 and they see a 3. It's going to be important to have the discussion of which one represents the length of just this side. So we can see that this 6 is actually talking about the length of the whole bottom. So that's not the one we're going to want to use. We want this 3. And this 2 represents this dimension. So first probably highlighting the dimension they need to use and then identifying the correct number they need to multiply by. So we can multiply to find that the area of this smaller rectangle, 2 times 3 is 6 inches squared. So here we're in a similar situation where we need to find the area of this bigger rectangle here, and we're looking at a couple dimensions. This right here represents this 3 represents this length, which is the length of the rectangle, so that's perfect. But we have a 4 and we have a 6, so we need to again decide we want the length of this the height of this entire rectangle. Which number represents that, the 4 or the 6? And we're going to help your child realize that the 6 is the number that they're going to need to use. And then they can multiply 3 times 6 to find that the area here is 18 inches squared. And finally, we'll take a moment to then add those together, 18 plus 6, to get a grand area of 24 inches squared. So we're going to take them on a journey of area and end up with being able to do something like this as our end goal.
Okay, so closing out our multiplication division section of this presentation, here are just some fun strategies you can try at home. These are not the only things you need to use with your child, but just some ideas to not only master multiplication, but also division facts. So things like making sure you're practicing fact families and using facts that they know so that both facts are being mastered. So moving on to fractions. Fractions in 3rd grade, this will be the first time your child sees fractions. In 2nd grade, they do a little bit with partitioning a shape into equal-sized pieces, but that term fraction and naming fractions is going to be very new in 3rd grade. So we start with fractions on a number line, and also we start with naming a fraction to build off what they learned in 2nd grade. So here, working on a number line, we can see that we have 4 equal-sized sections, and that where the 3/4 is represents the third of the equal-sized section. So this would represent 3rd, 4th. We also will be working a lot on equivalence of fractions. So you'll notice it says in special cases. We'll kind of talk about what that means, and we're also going to talk about comparing. So some things to know about fractions in 3rd grade. We are limited to the denominators 2, 3, 4, 6, and 8. So we're keeping things really simple so that with equivalencies, it's easy for us to go from 2 to 4ths, or halves to 4ths, or 4ths to 8ths, and so on and so forth. So we'll be working with 2 major models. We'll be working with the number line, as you saw on the previous slide, and we'll also still be working with area model. Area model can be circular, it can be rectangular, it can be a square, it could be a triangle. So anything involving area, which is more formal, more similar to what we probably are used to in terms of fractions. You'll notice that this target also says to explain. So here we have a sample of what that might look like to explain the equivalence. That is going to be a big part of 3rd grade of what to say for that. So we're really looking for them to talk about the size of the pieces and equal-sized pieces when they're explaining. So that is there as a sample for you. And when it comes to equivalent fractions, one of the special cases is that really the idea that 1 whole is the same as 4/4, or 1 whole is the same as 5/5. We're also going to go into fractions larger than 1, and so we'll learn that 5/4 is just, 1 more fourth past this and is the same as 1 whole and 1/4. So we'll start to build that idea of fractions larger than 1 in 3rd grade as well. When it comes to comparing fractions in 3rd grade, there's some specific pieces that we're going to focus on. And really what it is this second bullet here, compare two fractions with the same numerator or the same denominator. Because here, for example, when the denominator is the same, I'm talking about thirds. I mean, that's the same as talking about apples or oranges, right? What's more, 2 apples or 1 apple? 2/3 or 1/3? So it's easy for students to identify, oh, we're both talking about thirds, so clearly 2/3 is larger. When the numerator is the same, it's a little more tricky because you really have to think about the size of the piece. So I'm going to focus here, my numerators are the same, so let me look at my denominators. Which is a bigger size piece, fourths or thirds? I would prefer thirds. They're a larger size piece, so 2/3 are going to be larger than 2/4. So really that reasoning about their size piece is going to be very, very much stressed in 3rd grade. So lastly, we are still a work in progress and adding to our parent resources on our instructional videos website. If you go to any of the District 96 schools, you can hover on that word student at the top, click on grade level links, and then you'll see this icon here that you can click on, and it will take you to a page with all the grade levels with different videos. So many of the videos you saw tonight or today will be added likely, and we'll be continuing to add that as a resource for parents at home. Also, be looking for those parent letters, those family letters that we will be sending home. Those have links to other videos and give extra support and explanations to the targets that will be coming up in your student's curriculum. So thank you for watching and listening to our presentation. We hope this was helpful.